In the preceding movie, we coded some functionality that allows an object to move in the direction in which it's looking, and I left you with some kind of tantalizing cliffhanger that told you there was one small ingredient missing from the overall equation. If I go back to mono-develop and I take a look at the update function, there is something that is missing from here. In particular, it's this. This update function right now will increase the position of an object by taking its forward direction and multiplying it by its speed, so that every single frame it's updated by a constant amount. The problem is that across different computers, and even on the same computer at different moments in time, it may be able to sustain a different kind of frame rate. So for example, one computer may be running your game at 70 frames per second, while another one is running it at 40 frames per second. This means that this update function happens a different amount of times across different computers. And because of that, if your object is updating by a constant amount on each frame, different people are going to have different experiences of your game across the same amount of time. And this is bad, because it could be that 2 seconds on one computer the object doesn't reach its destination, but on 2 seconds on a different computer the object does reach its destination, and there's an inconsistency in that gaming experience. To correct this problem, we need to use the variable of DeltaTime. And effectively, DeltaTime is very, very simple. All we have to do to adjust this equation to make it work is simply multiply what we have already by time.DeltaTime. Let me just explain to you what DeltaTime is. DeltaTime tells you the amount of time in seconds that has elapsed since the previous update happened. So for example, every single game sustains a certain amount of frames, and time.DeltaTime tells you the amount of time in seconds that it took to complete the previous frame. So typically on a game that is sustaining a lot of frames per second, time.DeltaTime is going to be very small. But if we imagine for a moment that the game was sustaining 2 frames per second, then time.DeltaTime would be 0.5, because half a second will have elapsed since the previous frame, since there can only be 2 frames in a second. And if our speed, for example, was 10 meters per second and half a second had elapsed, we should be traveling 5 meters per second. And so max speed times time.DeltaTime, which in this case of 2 frames per second would be 0.5. When we multiply a value by 0.5, it is halved, and so we always travel the correct speed. By multiplying by time.DeltaTime, we make the movement and the transformations in our game independent of the frame rate, and they become instead based on time. And because time is a constant across multiple computers, it will always ensure that our gamers get a consistent experience. So I'm going to press Ctrl S to save that code and return back to Unity. Now I'm going to select the capture object here in the hierarchy panel, and its speed currently is 0.1. I'm going to change this to perhaps 3, meaning 3 meters per second. And when I press play now, we get an object that moves at 3 meters per second. And the great thing is I can put this onto any computer and it will travel always at the same speed. So that's how we can make an object move in the direction in which it's looking, and that movement is frame rate independent.